Hi guys, I'm here to do the square root method with you all. I talked to Miss Moser and I think I know a lot of you all like to have videos just in case you don't get it in class and need to just kind of look back at somebody teaching it again. So I'm going to keep doing videos. I might be tired when I'm doing this, so please bear with me if I make mistakes or need to just correct myself. But I'm going to try to knock a couple of these out tonight and get through as many as I can. For this unit, I think there's only 1, 2, 3, 4, maybe five more lessons to do. So and they all build off of each other. You're going to see in this one how we use simplifying expressions that you just did on Friday kind of play its part in this one as well. A couple of things I do want to talk about. I know that, or I did get a lot of grading done over the weekend. I came in and picked up a lot of your all the work from the entire week from all classes. So I got a lot of that grading done. I did have one project that didn't have a name on it. A couple of you all didn't turn one in. Reagan, I know you emailed me. Excuse me. And I got your map. Reagan, I will email you the project so that you can work on that. But I did have a couple of others that didn't turn one in. If you didn't turn it in, please make sure that you get that to Miss Moser and she will get that graded. I'm not going to do any more grading from here on out. It's all going to be Miss Moser. So if you have any missing assignments, please get those to her and she will get that graded and put in. I can't put them in Infinite Campus, the ones that I graded over the weekend, but I did put them in the grade book and you all did a great job. It was fun reading and seeing the hard work that you all put into it. It was really neat to see some of the things that you all talked about and the things that you thought about when you were doing these projects. So some of you all were talking about insurance and just different things. And a couple of you all did give your theme park names. I was really hoping to see more because I love the creativity with those, but your maps were really good. I'm trying to think of the names. Oh, and I had them. Shoot, maybe the next video I'll have them out and give you all shout outs. The ones that did names. I was really, really glad to see that some of you all did give them names. So anyway, let's do square root method. All right, so Pythagorean theorem, you thought that you were done with that. But Pythagorean theorem is what Candace is using to find the missing leg of her right triangle. In the last step of her work, she needs to solve this quadratic equation, which is b squared equals 64. Hopefully you all know what you have to do to solve that last step. Just take the square root. So square root of... let me write it out. B squared equals 64. Take the square root of both sides. So B equals 8. But Candace thinks that there are two values for B, which makes the equation true. She is absolutely right, because some of you all might be in your head saying, Miss Flick, -8 times -8 is positive 64. And you are correct. So you could have B equals plus or minus 8. Those two values make square root of 64 true. Okay, so 8 and -8 are the two values that could be the answer to that. But which one would make sense in this situation? It would be 8, positive 8, because you can't have a -8 as a side length in a triangle. Hopefully you all are like, can't have a -8 in a side length of a triangle. Okay, so moving on down, when simplifying a square root expression, we typically give the positive root, and that is called the principal square root. Principal So if you ever see that, that's that positive number in a square root when you're taking the square root. The positive number is called that principal square root. It's a positive one. But when solving a quadratic equation by taking the square root, we have to say all those solutions. So if it's 8, it could be -8 as well. So for these examples, you could have 5 and -5. And then you could have for x squared, square root of 81. I guess I should show you square root of both sides. So we're doing this. So this would be +9 and -9. And then hopefully you all are yelling these out as you're watching this video. +15 and -15. There we go. All right. So when using the square root method, that's taking the square root of both sides of the equation to, let's all say it together, isolate the variable. Because that's what we're doing when we're solving for a variable. We have to get it all by itself in order to solve for it. So here are these situations when we would need to use the square root method. You're like, oh my gosh, there's so many different methods, and there are going to be a lot of methods in this unit. So just get ready. Put your big girl pants on. We're going to use a lot of different methods, kind of like with factoring. There was difference of squares. There was perfect square trinomial. There's going to be a lot here too. Okay. So the first time when you would use square root method is when you've got like x squared is equal to a value. So like x squared equals 20 or x squared equals 25. That's when you would take that square root of both sides in order to solve for x. Next, another time we would use it is when the middle term is missing. So when the middle term is missing, let's just look at this example right here. We've got 2x squared minus 5 equals 13. So to solve for that variable and isolate it, we would, first step, hopefully you all know, we would move that, we would combine our like terms, so add 5 to both sides, and then divide by 2, and then take the square root of both sides to solve for x, because we need to get rid of that exponent. We need to get rid of everything that is with the x. And then the last one is where there is a binomial squared. So those two terms right there, that binomial that is squared, x minus 6 squared equals 10. And we're gonna do some examples of that as we go on. Are any of my girls out there trying to get Love is Blind reunion to play? I don't know why I've been trying to watch this all night long, and maybe it's going to come on now. Okay. Sorry. There's just some things that you just want to watch and do, and it's still not working. Okay. All right. So, hopefully you all can do the first one on your own, but we would add 100 to both sides because we are solving for x. We have to isolate it. And now we've got x squared equals 100. And see, here's where you would use that square root method. Square root both sides, x equals, and we have to list all possible solutions. So this would be plus or minus 10 because square root of 100 is 10. Is 10, not 8, is a 10. Anyway, I want you all to do number 2 on your own. And then number 3, I'll come back to the answer for number 2 for those of you that are actually going to do it on your own. Okay, so for number 3, this is where, let me just explain number 2. Number 2, if you look at when to use the square root method, this is when the middle term is missing. And I was talking you kind of through that example earlier. That's when you would use number 2. Number 3, this is when it says there's a binomial squared, which is what we have right here. So first thing that you're going to do is square root. We need to get rid of that squared, so we're going to square root both sides, and that gets rid of that squared. Okay, so we have x plus 5 equals square root of 144, which is positive 12 or negative 12. Stick with me. I want you all to do this. You're going to write eraser. Come on. I'm going to change colors here. So I'm going to write off to the side. We've also got x plus 5 equals negative 12. Okay, so we have to write out both equations because we're solving for negative. We've got square root of 144 is positive 12, and then we have negative 12 as well. So we're going to have two separate equations that we need to find solutions for x. So we need to subtract 5 from both sides, and x equals 7. And then the other side, subtract 5 and subtract 5. And now we have x equals negative 17. Makes sense? Got it? All right. I'm going to go on to, these are going to get a little bit more complex, but it's really not that crazy. All right. So for number 5, we're just solving an equation. We're adding like terms, whatever we need to do to solve for x. So for number 5, first thing, I'm going to add 4 to both sides. Whoops. Come on. Add. Sorry, my pointer is not working. There we go. Add 4 to both sides. Cancels it out there. And now we have x minus 3 squared equals 4. All right. So now this is just like when there's a binomial squared. We're going to square root to get rid of that squared, square root. So we have x minus 3 equals positive 2. And then we have x minus 3 equals negative 2. You have to list both solutions. So I'm going to add 3 to both sides. And then you've got x equals 5 plus 3 plus 3. X equals 1. Boom. That's it. All right. Yeah, I'm going to do this next one with you for sure. Okay. So for this one, so I was just looking at my notes because I went through and did them all first. Okay. So first thing, hopefully you all know, we're going to add 14 to both sides because we're combining our like terms first. And now we're left with 3x squared equals 24. All right. Now we're trying to solve for x, so we have to get rid of everything that we can first. So we're going to divide by 3. And now we have x squared equals 8. What do you do next? Miss Flick, Miss Flick, Miss Flick. I know Tyler's back there like raising his hand. Izzy's reading a book, and then she'll look up and say, oh, square root. I know y'all know how to do this, so hopefully you're not waiting on me to do everything. But we're going to square root both sides, and we've got x equals, and you're like, but 8 isn't a perfect square. It's not a perfect square. So what we're going to do now is x equals square root of 8. You can just leave it like that, but that wouldn't be right. Who knows why that wouldn't be right? I know lots of you all out there know it. Because in simplifying expressions on Friday, see, I told you it would come back around, we can bring that down. What are some factors of 8? 8 and 1 and 4 and 2. Are any of those perfect squares? Yes, they are. 4 times 2, square root of 4 is 2. It's a perfect square. So x equals same thing as square root of 4 times square root of 2. Square root of 4 is 2, so x equals plus or minus, because square root of 4 could be a positive 2 or a negative 2, 2 square root of 2. A lot of square roots, a lot of plus or minuses, I know. But hopefully you kind of get that, where the simplifying expressions came in. All right. I want y'all to do number 7 on your own. I'll come back to it and give you the answer. All right. Number 8. So let's look. Angelica, what a name, needs to solve the quadratic equation shown. Can she use the square root method? I almost just gave away the answer. Explain why or why not. Okay, so if you sorry, my husband is just being funny upstairs. So if you look at this, and hopefully somebody is going to look at that and think, oh yes, I remember from when we were factoring polynomials that this is a perfect square trinomial. Because look, 25, that's a perfect square. The number in front of your x, that is a 1, and that's a perfect square. And in order for it to be a perfect square trinomial, we have to look at that middle term. So square root of 25 is 5. And then square root of 1 is 1. 1 times 5 is 5. And then we have to do that multiplied by 2. So 5 times 2 is, voila, 10. So this is a perfect square trinomial. So we can just set this up as, x plus square root of 25 is 5, plus 5 squared equals 16. And see, this is where we can use our square root method. So we're going to square root both sides. And now we've got x plus 5. Equals 4. And then x plus 5 equals negative 4. And then just solve. So x equals minus 5, negative 1. X equals minus 5, negative 9. There we go. Boom. So easy, right? You don't like Miss Flick? I don't think so. All right. Same thing, number 9. I'm going to give you 3 seconds to see why we can use the square root method on that. Hint, look at number 8. I'm going to give you my eyes. 3, 2, 1. Square root method for this. This would be x minus 8 squared and then equals 2. Because 64 is a perfect square, the coefficient in front of, or your a, is a perfect square, which is 1. If we do square root of 64, which is 8, times 1, we get 8. 8 times 2 is 16, which is our middle term. The reason why I use negative 8 is because negative 8 times negative 8 is positive 64. Negative 8 plus negative 8 is negative 16. What? All right, I'm going to leave you to that to solve. Number 10, Calvin drops his hat from a bridge. He's pretty far off the ground, 256 feet above the ground. The height of the hat is y equals negative 16t squared plus 256. So using this, we can calculate how long it's going to take for that hat to land on the ground. So we're going to set it up as negative 16t squared plus 256. And then let me make sure, because I wrote this out. I want to make sure that so we're going to start off with this equal to 0 because we want to know when it gets down to the bottom. Okay, that's y is the height. So we want it to land on the ground. So we're going to subtract 256 on both sides. And now we have negative 16t squared equals negative 256. Oh, here comes my dog. You want to see my dog? There he is. He's over it. And then we've got, I'll do this out to the side. We've got t squared equals 16, square root of both sides. You have t equals 4. Now, don't start hollering at me and saying, but you said we would have 2 separate solutions. But for this, we're only going to have one because you can't have negative seconds when we're talking about time for something to fall to the ground. It's not taking him negative 4 seconds to fall to the ground, that hat. This is the only possible solution for this would be positive 4. Okay. All right, now we're going to do systems of equations. I love systems. Okay, and I know you all just love them too. Okay, so we've got our systems of equations. It says to use what you know about systems to solve and then use the square root method to finalize it. So for this, the first thing that I did when I saw this earlier is I know that both of these equations are equal to y. So this is like saying y equals 2x and then y equals 4. You could say 4 equals 2x because those are both what y equals in order for you to solve for x. So I'm just going to set both of these equal to each other. So I've got x squared plus 2x minus 36 equals 2x. Okay, we're using that substitution method. We're taking out the y in the first equation and we're substituting in 2x because that's what the second equation tells us that y equals. And now we're just going to combine our like terms. So subtract 2x. And now I've got x squared minus 36 equals 0. And I'm going to add 36 to both sides. Oops. 3 looks wonky. And then I've got x squared equals 36. Square root of both sides. What? X equals 6. And x equals negative 6. Okay, so now it's saying to find the solutions, and we've got what x equals. We just need to find out what y equals for both of those. So all you're going to do now is substitute in x, the x value, wherever you see an x to solve for y. And we can put x in right here. So we can say y equals 2 times 6. And that's y equals 12. But we also have to put in the negative 6. So y equals 2 times negative 6. So y equals negative 12. So our two solutions, if we put them together, what we put in, our input and our output, our two solutions would be 6, 12, and then negative 6, negative 12. I guarantee you're going to have a question like this. Well, I should never guarantee, but probably on K-Prep. All right, so last question. Here we go. So Jeffrey asked, or used the square root method to solve the equation. What is his error? I really hope that you all can see it right away, what he did wrong. So x minus 5 squared, or the quantity of x minus 5 squared equals 20. It looks like what he did first is he was like, I don't care that it's in parentheses. I don't care about that exponent. I'm going to go ahead and add 5 to both sides. I think that's what he did wrong. So he, right there, he went off the rails. So to solve this, I'm going to rewrite it over here. X minus 5 squared equals 20. All right, I want you all to actually do that one on your own. Look at it. I think that one's yeah, I'll come back and do that one. I want you all to try to do that one on your own. I'm going to go back and give you some answers to some of the problems that I hope you did on your own. So number 2, 4x minus 8 equals 0. Oh. All right, so if you worked on this one on your own, we would add 8 to both sides. And you've got 4x equals 8 squared. X squared equals 2. Square root both sides. And 2 isn't a perfect square. So how you would leave that as an answer, it's just x equals plus or minus square root of 2. There aren't any factors where you can break that down and simplify that expression. Okay. Number 4, how are the steps to solve number 3 different than 1 and 2? That's just it's different because the first thing that you do is you get rid of that exponent by squaring both sides or taking the square root of both sides. That's really it. Okay, number 7. Let's see. Okay, this was a straightforward one. So first thing is divide both sides by 2. You can't take the square root of that first because we have that 2 on the outside. So we need to get rid of that first. So now we have x plus 1 squared equals 49 divided by 2, or 98 divided by 2 is 49. And now we're going to take the square root. So x plus 1 equals 7, and then x plus 1 equals negative 7 because square root of 49 is 7. And then just subtract 1 from both sides. So x equals 6, and x equals negative 8. There we go. Hopefully you guys got that one right. Okay, so let's do this last one. I'm going to change colors. I'm tired of blue and too green. So square root of both sides. So we have x minus 5 equals, square root of 20. Simplifying expressions. 20 is not a perfect square, so you have to ask yourself, can I simplify this down? Factors of 20. We've got 20 times 1. Neither one of those are perfect squares. 10 times 2. Neither one of those are perfect squares. But 4 times 5, that's a perfect square. So we have x minus 5. I guess I can take away the parentheses because we already took the square root. Oh, and I drew it again. Sorry, x minus 5 equals, and this is the same thing as square root of 4 times square root of 5. Square root of 4 is 2, and it's plus or minus 2, and then square root of 5. I know, a lot. So we're going to add 5 to both sides. You all have probably seen this before, an answer like this. All that we can do, because we're not multiplying or dividing or anything like that, is just 5 plus or minus 2 square root of 5. So it's a lot more complex of an answer than what his original answer was. That brings me to some of you all, your simplifying expressions homework that you turned in. You all probably know who I'm talking to. There were about 4 of you. This flicks eyes. That just took your calculator out and said if it was, I don't know, square root of 200, I don't know. You just typed that in your calculator and you wrote that down. You did not simplify the expression. So you did not get full credit. So those of you that did show me work, and I mean, not everyone showed work. Can't win them all. But if you just typed it in your calculator, not giving you full credit. You have to know how to simplify that expression. So Miss Moser will be putting those in over the course of the week probably. I think that's it as far as square root method. If you have any questions, y'all know how to email me. Tabitha, I did see your email and I saw that you turned it in and you did great on it. So you did good. Gracie, same thing with you. You did fine. You guys are good. But Reagan, I will, in case you don't find it, I hope you do find it, but I will email you a copy. And I think that's it. Y'all have a good night. Bye.